My name is Ebiti Edide from First Click Limited. I assume you are watching this video because you want to learn how to program. So have you been searching for how to learn to code for beginners this 2020? Where and how to learn programming online? How to learn programming at home? Beginners ask all the time, which language to start with? No! Start by learning logic, design and concepts. You will learn how to start coding today. However, not in a programming language that the computer understands, but in a language you understand, and that is pseudocode or structured English. Pseudocode is really structured English. It is English that has been abbreviated to look very like high-level computer languages. You can easily read and understand any programming language after learning pseudocode. I will walk you through your first programming exercise ever using Flowchart and pseudocode. Well, about Flowchart, there are things you need to know before we can continue. I am allowing you to watch how to move things around in Microsoft Visual. Just follow the mouse movement. These are the basic flowchart shapes we will be using to build our program's algorithm and their meaning. Pause the video and get acquainted with them. Before you can write pseudocode, you must understand 6 basic operations that a computer can perform. A computer can receive information, number 1, either from a keyboard, file, or even a database. I'll repeat that again. Number 1, a computer can receive information either from a keyboard, file, or even a database. Used keywords like read, get to receive such informations. For example, read student name. Notice that each line starts with a verb or an action word, followed by one or more nouns to indicate what the computer should do. Number 2, a computer can put out information. Number 3, a computer can perform arithmetic. Number 4, a computer can assign a value to a variable. Number 5, a computer can compare 2 pieces of information and select one of 2 alternative actions. Number 6, a computer can repeat a group of actions. Okay, so now that you know the 6 basic operations that a computer can perform, let's start our first programming exercise. Okay, so the first thing to do when you're faced with a problem is to define the problem first. Somebody gives you a job to do, you need to define the problem. Yeah, you need to know what the problem is all about. Of course, this will involve carefully reading and understanding the problem. There needs to be a problem statement in place, or what we call a requirement statement, because it's a small program that we're expected to write from what you're saying. But for a proper project, we call it requirement document or business requirement document, BRD. But here, just narrow it down to a problem statement. This is the document that is going to be guiding you. If there is no document, then you're just going to be running into too much problems, because there's really nothing to follow. It's going to be a haphazard kind of work, which may end up in program not working. So here we have a simple problem statement stating a program is required to prompt the user for the maximum and minimum temperature readings on a particular day. Then it says calculate and display to the screen the average temperature. So our program is expected to calculate and display the average temperature of the readings that were gotten on a particular day. So I say stage 1 is making a problem statement. Stage 2 is having a defining diagram. That statement you have up there, you are going to break it up to a defining diagram. The defining diagram comprises of 3 columns. What the inputs for the program will be, processing, what you will ask the computer to process for you, the actions it will take to give you, and then of course there will be output. A computer, when given inputs or what we call variable or even data, can take those inputs and based on the processing instructions you gave it, which is what we call processing here, can then give you an output. So I said a computer takes an input, does some processing with the input, and then give you an output. That's why we're having the defining diagram, where you will state what the inputs are, what the processing should be, and the output to achieve the average temperature that we're trying to calculate with this program. So for this defining diagram, straight ahead, look for the action words, in other words, verbs, or even adverbs in the defining statement. Pause at every beginning of an action. Take that action and list it as what you want the computer to process for you. Now, I always start from the processing instead of from the input, because as I list all the actions, then I'll be able to tell clearly what the inputs should be, meaning even the ones I couldn't see on the defining diagram, rather on the defining statement, I'll be able to figure them out and list them alongside the ones that I've been able to figure out on the input, and likewise the output too. So always start with the processing. It's easier that way. So for instance, the first action word here is prompt the user for maximum and minimum temperature. The computer is expected to prompt the user for maximum and minimum temperature. Okay, so I'll start with the prompt user for 1 maximum temperature, then prompt user for minimum temperature. Instead of prompt, I'll just use a word closer to a programming language, which is get. Then I'll use it in capital also. So see what I'm doing now. I'll say get maximum temperature instead of prompt maximum. You could use prompt if you want, but I'll use get maximum temperature. Then I'll list get minimum temperature. So we already have 2 actions that we want the computer to achieve for us or process for us. Then we go back to the defining statement to look for the next action. There is this, we come to calculate. is another action word, calculate. Yeah, calculate. What do we want it to calculate? Calculate average temperature. There you have it. Calculate average temperature. The next action word. So we list it. Calculate average temperature. And then we go back to our defining statement, and the next action word is right there after calculate, which is display. What do we want it to display? Display average temperature. So I'll list it as our last action word, which we want the computer to process. So I'm changing display to print. Same thing. Print average temperature. Okay, so now, of course, the input already stirring, some of the input already stirring in our face. We're getting maximum temperature. Is an input. We have to get it from somewhere. The computer will not manufacture it. You have to give it to him. Maximum temperature. Somebody has to feed in maximum temperature, either from a text box, on the screen, and then we'll have to feed in minimum temperature and click submit. Then the computer has it. The computer will receive it, and then do what? When the computer will get the maximum temperature, get the minimum temperature from the user who keys it in, and then we'll do what for you? Do step 3, which is calculate average temperature. Yes, it will take the 2 inputs and do the calculation of average temperature for you. And after that, it will do the action of printing the average temperature on screen. So the output here is obviously average temperature, because the defining statement is very small, so we don't have much input or output. From what we have, this is it: input, maximum temperature, minimum temperature, processing, get maximum temperature, get minimum temperature, calculate average temperature, print average temperature, output average temperature. So we go to the next step, which is step number 3. Step number 3 is develop an algorithm for your defining diagram. So normally we're going to use a flowchart first, and then we'll go to interpreting, we'll go to pseudocode, but first flowchart, so that you can see the steps involved in writing this program pictorially. You can have a visual of it. When you write a program this way, it's easy to see how your logic is flowing and to see if your logic is correct. It's very frustrating to go ahead and write codes without having done a design like this, and then afterwards there are errors or bugs, and then you sit on the computer for hours trying to debug it. That's why we use these methods. That's why we're doing. Normally after writing this algorithm, we're supposed to text check it. Okay, so what's the next step? What we have next, so after putting the start diagram, we go to our first processing, which is get maximum temperature. In flowchart, this is what we use for input and output. This very shape, the slanted triangle, you can call it. The next step, as you can see, we're going sequentially, and of course I combined the first 2 steps here in this diagram. Get maximum, minimum temperature. I don't need to repeat it. So we'll finish asking the computer has received maximum, minimum temperature. It goes to the next thing, which is to calculate the average temperature. Okay, then we'll go back to see what the next action is. Next action is to print the average temperature that has been calculated, to print it to screen so the user can see the result. So there we have a print average temperature. We don't have any other processing, so every program must have a start and an end or a stop. Computer must know where to start from and where to stop. So we're going to put the stop sign now, which is the same as the start diagram, or rather the start shape. Same shape for start and stop in flowchart. So there we've told the program to end. Start, get data, do some calculation, print the result to screen, and then stop or end. Then we'll go to the next step, which is writing the pseudocode from using the flowchart. We're going to write the pseudocode, or what we call structured English. You see, I told you, when you want to learn programming, learn to write the codes in structured English first. After you've made a flowchart, you design your flowchart to go exactly the way you want your logic to go. Then code it with pseudocode or structured English. Because as you see, structured English is close to or resembles or has a resemblance of any programming language syntax, but the structured English is something you can understand. It's English, but it's structured, okay? So you can read it first and be sure, that this program is working or is going to work, before you convert the structured English to any programming language of your choice, which you will learn during this period. With this, you will start programming without realizing that you've already started using a programming language, because it's very close. Pseudocode must also have where it's starting from and where it ends. So I'll call this particular block of code calculate average temperature. Then I say it will end here, Then the statements are going to be written inside the block. So I do an indentation, just one tap. So these flowcharts are each of the steps that we're going to be converting to pseudocoding or structured English. And obviously the first thing is to get the maximum and minimum temperature. So I'll come here and write that. First step, get maximum temperature. That's our first step from the diagram. Second step, get minimum temperature. Third step, calculate average temperature. You see how the flowchart is giving us direction? Okay, so normally in maths, average temperature is calculated by the sum of figures given divided by the count of the figures. So you sum the figures given and then you divide by the count of the figures. That's the average temperature in maths. A programmer doesn't need to know this. The industry where you're developing for, the people who have to tell you how to calculate the average, or whatever business it is they're doing, they have to tell you the processes. But this is simple math, so we know that average temperature is sum of whatever figures you're given divided by the count of the figures. Okay, that's how to get average temperature. Average rather. So I'll quickly turn this to our business here, which is average temperature. So I quickly added the temperature. And notice this underscore sign I just brought in. That's why it's structured English. It's not straight English. So you see, it's still English. You can read it average underscore temperature, maximum underscore temperature. So pardon me, I'm going to add that for maximum underscore temperature, which we read up there, and then the minimum underscore temperature, which we also got from the user, as input. So you see, that's turned to structured English now. Get maximum and temperature is one word. Because it's one word, I'm using underscore. Minimum temperature, one word. Average temperature, one word, I use underscore. Then I'm doing the average now. Maximum temperature, one word, using underscore, plus minimum temperature, one word, using underscore, divided by 2. So here we have only 2 figures, maximum temperature and minimum temperature. So we already know that we're going to add 2 of them and divide by 2, because there are only 2 figures here. Then normally in maths, we use bracket open and close to group, meaning we want this inside the bracket to happen first before any other thing. So we'll do the next step, which is print. We're printing what we got from calculating the average temperature. So there you have it, print average temperature. So this is the pseudocode. There you have it. Now it looks like a programming language, very close. So if I was to code, of course we're going to code this just to show you how it will run. But that's not our focus for now. Once you have this, you can then code. It's easy to code. Okay. So let's look at it again. So we wrote our first process, which was to get maximum temperature. Then we wrote get minimum temperature. We did the mass. We grouped the maximum temperature plus minimum temperature, meaning do this first before dividing by 2, and then give whatever answer you have to average temperature. In a real programming language, we call it assign. So after doing the mass, assign the value to the variable called average temperature, and then we did the next step, which was to print the average. Okay, so that's it. From here we'll just code it and show you how it runs, just to arouse your curiosity, but don't concentrate on coding for now. Just concentrate on learning what I'm showing you, so that in no time you can start programming. So this is my NetBeans IDE. IDE is Integrated Development Environment. This is NetBeans 8.1. This is where we're going to be running our code. I'll be coding that pseudocode into PHP. PHP is Hypertext Preprocessor. It is a server-side scripting language. Okay, more on that later as the training continues. You will get to understand what a server-side scripting language is. For now, let's just concentrate into coding that pseudocode into action. So I will have to create a new project, but before I do that, I'll go to the Apache root folder and create a folder there called First Click Training, which I already have. Okay, so I'll create that and I'll tell you why later. So I'll create that folder and then I go back to my NetBeans IDE, click on File, New Project. I want to create a PHP project and a PHP application. These two are already highlighted, so I click Next. This is why I went to create that folder. NetBeans wants to create this folder in Documents, NetBeans Project, blah blah blah. I don't want it there. I want it in my root folder for convenience. So, of course, I'll give this project a name. Let's call it First Click Training. And that we locate that folder called First Click Training and highlight it and click Open. So it's there. So go ahead and finish. Of course, there are other things here. If you want, you can do, but I actually am happy with this. This is how I want to be referencing my web application on this local machine. So I'm happy with this. I don't need to go forward. I'll just finish here. Okay, and so NetBeans has created First Click Training. Okay, with two folders, source files and include path. This is where you want to be putting your files, source files. Okay, so I'm going to create a new file, a PHP file, which is already highlighted. So I click Next. What do I want to call my file? Index. Because every web application or website must have an index page, no matter the language used in writing the page, whether be it PHP or HTML or whatever is used, but there must be an index page. The index page is the home page. Okay, so the server knows that to be the home page, okay, of any project. Index dot whatever it is, whatever language is used. So in this case, this will become index.php since we're creating a PHP file. Okay, so look at it here. So I go ahead and click Finish. So it creates this page. We'll go ahead and copy our pseudocode and paste it here. Okay. So we have our pseudocode here now. Okay. Remember, it's not yet a programming language. It was just written in structured English where we understand. Okay. Okay, so notice my indentation. One tap from the heading of the code. Okay. Okay, so what I'm going to do now, I'll turn all of this pseudocode into PHP comments. Okay. Now, if we were to code this into a function, then I'll be using this, the header, or rather the name for this block of code, which we call calculate average temperature. If it was to be a function, which of course you will learn in the course of the training, I'll simply open this there. You see, immediately I open that, immediately I type bracket open PHP, closed it for me immediately. And then I'll open with curly brace. Now you have started learning how to write PHP itself. And then I'll come to the end and close the curly brace. But we're not going to be writing this as a function, since that will be coming in a later video. So I'll just go ahead and comment out the line. We don't need it. Okay. And of course I'll do the same for all the statements. Just follow what I'm doing. So this is how to comment out a line of code with double forward slash. Okay. But if I wanted to comment out all of them at once without going through if I wanted to comment out all of the block of code without having to comment out single lines, what I will use is this. Just watch, because now you've started learning PHP itself. You see, that comments out the whole block of code. I just start from where I want and put forward slash and star, and where I want to end, I put 1 star and 1 forward slash. Okay. But that's not what I want to do. So I'll put back. So now we have our comments: get maximum temperature, get minimum temperature, and then the rest of the statements. So what I'll do next is to get maximum temperature. I'll just copy this maximum temperature and put it on this side of the code. In PHP, how you create a variable is by putting this sign in front of your variable. Okay. So now we've created a PHP variable called max_temp, that is maximum temperature. In PHP, we don't have to tell the computer what kind of data type to expect. If not, some language would have written the data type alongside with the declaration of the variable. So remember assignment character, this equal sign. Okay, so I put it there. So what do I want to assign to maximum temperature? Let's say the maximum temperature was 32. 32. So we put 32 there, and then in PHP, every line of statement must finish with this sign, a semicolon. Okay, so we've written our first line of code there successfully. Please notice that, of course, PHP would have received this information from maybe a form text box, but we're not going to go into all that now. That's why I'm just passing this value here directly to this temperature. Subsequently, in other videos, you will see how to do that. Okay, so the next thing is what? The next line of code is to get minimum temperature. So start with that sign, and then you put it there, and then the assignment character. So let's say the minimum temperature was 16 degrees, but we're not putting the degrees. PHP doesn't know that. So that was 16. So now this computer knows that the data type you're assigning to maximum temperature and minimum temperature is integer rather. So having done that, we'll go to the next line of code. We'll copy it the same way we did for other ones. Paste it on this other side of the statement. And then for average temp, add that sign, the variable sign. For max temp, add that variable sign. Remember, computer can do arithmetic, so it knows about this sign called plus. It's the same thing for maths, it's for addition. So we'll add this. And then I said that every line of code must terminate with this sign. Now PHP knows what you're talking about. So that has become a PHP code. And this bracket, remember, is for grouping. So PHP knows that it must first add maximum temperature to minimum temperature before dividing by 2. And then the next thing is our print. So we have print what? Print average temperature. So here we're going to copy only average temperature because we will use the word echo for print in PHP. So we say echo, which is a PHP keyword, you're seeing it there, highlighted, which is used for print. Echo variable average temperature, and we close the line with the semicolon. So our code is complete. Now, see how simple it was to turn all of this code into a PHP language. Okay. So I've saved it by clicking Ctrl S. Let's go and run the code and see. So we'll go to our web browser. So here we are in our web browser. We type local host, first click training, and then, like I said, if I press enter, since it's an index page, PHP, rather the web server will load it. I don't have to put the particular page name since it's an index page that we're working on. So I press enter. And there you have it. See the answer, 24. Okay, that's the average temperature. To make it clearer, what we can do is add a little statement to it. So we can say echo. Watch. We can say echo. And then we open either double quote or single quote. Open and close. This is our average temperature for today. And then notice the red sign, and this red sign is saying syntax error, unexpected average temperature, blah blah blah. What it's saying is there's something wrong with this line of code. Yeah, because I need to put, when trying to join a statement to a variable, PHP expects me to use a concatenation sign. So see this dot I put here is called concatenation sign. So that's what will join this statement that I wrote here to this variable that I wrote here. Okay, that's what's joining them together. Without this, we'll be seeing that error message. And notice, to join it, I said use either a single quote or a double quote. Doesn't matter if it's a single quote or double quote, PHP understands it. So Ctrl S, I'll save it again. Go back to that browser and refresh. Okay, so now we have, this is our average temperature for today. Okay, if I wanted to space it, since it's joined together, if I wanted to space it, I come back here, come here, and put a space between the colon and the single quote, and save again, and go back there and refresh it. So there is a space there now. Okay, so there you have it, your very first programming exercise. Wow. If you do not follow the method I have shown you in this video to learn programming as a beginner, you may just become frustrated because of the amount of hours you will spend trying to debug and correct logical errors in your code. Trust me. So this is only a beginning of a series of training that we want to do to help people learn programming, with about 14 videos here on this channel for free. Okay, so what you just need to do right now is to go ahead and subscribe to this channel down below if you haven't already done so, so that as we upload the follow-up videos, you will see them immediately. The more we get subscribers, the more we are encouraged to continue the training. Help keep the training alive. Also, click on the like button if you like this video, and do not forget to share to others who have same interest so they can follow through with you. All questions regarding this video should be asked here in the comment section below. We will do our best to respond and guide you through any challenge, especially to those who are subscribed to this channel. I will see you in the next video.